Before we start with the presentation, maybe it's interesting to have a quick idea of who is attending the webinar. And maybe instead of just giving us everybody's a presentation of themselves, maybe it's good to just have an idea on which country you are from. So we probably will have people from the Northwest Europe area. So I'm wondering if we have French people in the room, and if so, maybe you can give us a thumbs up with the reactions, and then we have an idea of people from France are here. I see already that Dries is from Amsterdam, so he's representing the Netherlands. Are there other people from the Netherlands? If you can just use a thumbs up. So we have Dries from the Netherlands. We have maybe people from, we have somebody from Thailand. Welcome on this webinar. Irish people, I think we have 3 of them in the room. All right. From Belgium, I recognize a lot of names, and we have people from Belgium here. Elsie is from Belgium. Koen is maybe from Belgium. Christine, right? And then I think it's all the country. No, Germany. Is there somebody from Germany here? Nobody from Germany. Okay. And then we have one person who is not from Northwest Europe, but of course, very welcome for them. Right, let's start with the presentation. I'll share my screen. Where is it? If everything is okay, then you see now my presentation mode of the screen.
Yeah, we can see everything's done.
Okay, thanks, Jill. Fine. So as said, we will give you today a kind of beginner's guide on aquathermal energy. And this presentation will last for around 30-45 minutes. And we will have still afterwards time for a Q&A session. So what we hope to learn you today is what is aquathermal energy, how does it work, what is the potential of aquathermal energy, so what can you expect from it, and we will also cover this with a case study of a project which is realized here in Belgium. And then, of course, we will end with the call for early adopters, which we are looking in the framework of Aquacom. Maybe you heard already about Aquacom because you are also present in this seminar. But Aquacom is an Interact Northwest Europe project. So there are members representing, or there are organizations here in this meeting or in this project which are representing the different countries in the Northwest Europe. And our goal is to empower energy communities and empower them by knowledge of aquathermal energy. We do that on different sites or different ways. On one hand, we will develop 3 pilot projects in which we will realize an aquathermal installation, which also will prove then the potential of the aquathermal systems. So we have a pilot in France, we have one in Belgium, and we are developing also one in the Netherlands. The pilots are not only just pilots to prove the technology, but they are also our study objects for the early adopters, because it's also a big part of this project that we take 15 early adopters along a project development and learn them what aquathermal energy systems are, how they are organized, what pitfalls they can expect, and so on, and also what kind of business models we can offer them in developing this type of projects. So that's the goal of the project. It's a 4-year-long project, and we are now 1 year already. We've done already 1 year of the entire project. As said, so there are organizations from different regions. The project lead is in Ireland, is Balaura Development. And Then we have in the Netherlands, we have the province of Friesland, who is partner. And together with the province of Friesland, we also have the village of Vlieland and the island that is also part. In Germany, it's the University of Oldenburg that is part of the consortium. In France, we have it's a long name, but it's an organization focusing on using renewable energies in energy systems. And we have many organizations from Belgium, in which we have EcoPower as an energy community, Groep Huizentruid as a developer of living projects or housing projects, Extracts, who is an engineering company focused on aquathermal energy. And then we also have Rescoop. Rescoop is based in Belgium, but of course is operating over the entire Europe and is representing the energy cooperatives focusing on renewable energy. So that's the project. We'd like to give you an introduction, so it's already good to tell you what we understand about aquathermal energy. For us, aquathermal energy is using surface water, so we have a focus on surface water, and that can be a river, a lake, a canal, as a source to sustainable heat or cool buildings. So it's surface waters. It means it's a natural source that we will use, and we will connect that to residential buildings or industrial buildings, but mainly it's used for residential buildings and heat those facilities. Aquathermal energy can be narrow or broad, and sometimes you hear also the terminology aquathermal energy when people are talking about using drinking water or using wastewater. Wastewater can be wastewater from industrial applications, and where they have an excess of heat, which still can be used, or it can also be the sewage water, which can also be a part of an energy source for systems. We will focus only on surface water because mainly it's a main source of aquathermal energy if you compare to the amount of energy which is present in all the water that is available. If you would make an evaluation of the availability, then it will be around 80% energy that you can harvest from surface water, 15% from wastewater, and 5% from drinking water. So it's the majority of the energy is really present there. And of course, it's also a source which is all around. If you just evaluate and plot all the water ways we have in the Northwest Europe, then you really see a very blue map where you all have very thin lines of rivers. So it means that we as people live very close to waterways. And it's of course logic. We did that. We used those waterways in the past for a lot of applications, and we used it for transportation. We used it for food applications, for irrigation of our fields and so on. So that's why we are settled around rivers. And of course, today we also are planning to use those water bodies or waterways as an energy source. And important, it's always our goal to use it as an energy source with respect of nature. So it means that we will not change the ecosystem's properties by harvesting the energy. If we say we are going to implement an aquathermal energy system, therefore we need three main parts. On one hand, and it's the most important part, we need something that can extract the energy from the surface water. That's the first part. The second part is that we need an installation that can elevate the temperature from the water body to a temperature level which is useful in heating applications. Typically in Europe, we heat our houses at a temperature level between 50 and 70 degrees. So that's not a temperature that we can take out of a river. And the rivers are, depending on the time of the year, they change from temperature around 5 degrees in winter time till 20 degrees in summer times. So that means that still that step of using a heat pump is important to bring it at a decent level. That said, it means also that surface water, which is at the level, at the temperature of 5 degrees, still can contain a lot of energy. Energy can be stored at low temperature or can be stored at high temperature. So the amount of energy can be huge in a river, only it is not always at the useful temperature level. And that's why a heat pump, or that's the magic that a heat pump will do. Of course, then in the third, and then once after the heat pump, we have to distribute the heat, which was produced by the heat pump, through the entire building. And that's the third part, that's your distribution system in the buildings itself. We will always have those three components, so those three parts in an aquathermal energy system. They can be small, they can be large, depending on the size of the project. And especially also on the first one, it can be an installation that is connected to a river or that's connected to a lake. And based on the property of the water or the type of water, it will also be a different installation that we will put there. But that later on, I will explain more about that. Maybe first focus on the heat pump. And why is a heat pump a very sustainable or installation, or why can using a heat pump be a part of the energy transition? And therefore, I would like to start with first compare it with a traditional heating system as a gas burner. Most people have a gas burner at home where they heat their facility, but at the time they are using the gas and heating the water which is distributed in the building, there is a certain amount of energy loss. A heat pump tries to use another source instead of gas as the heat source. It can be connected to or an air system. It can be connected to a ground system as a geothermal system, or in our cases, it can be connected to a water stream. The heat pump itself will take energy out of the water, and as I said, it's at a low temperature, but contains a lot of energy. And to elevate the temperature from a low temperature to the required temperature, therefore, a certain amount of electricity is required, and that's what we call it. That's during the compression step, which is in the heat pump. Then we can elevate the temperature. Compare it as using your bike pump. If you have a bike pump and you put your finger in front of the bike pump and you compress the air which is in there, you will feel that it starts to become hot, and that's really what also the heat pump is doing. But then it's not a person who is compressing, but it's an electrical driven compressor. So that means we need a certain amount of electricity. That amount of electricity that is required is typically, and depending on the output temperature, it's typically 1/4 of the total amount of heat that is produced. That means that the heat pump will take 3 parts of the energy out of the surface water. He adds 1 part of the energy from the electricity grid, and based on that, he can produce 4 units of heat. So it means also that the efficiency is at that time 400%. So it's a very small part of electricity that we use for a huge amount of heat that we can produce. Still, the production of the electricity can be sustainable or non-sustainable, depending on what is the source. But it will give you already a huge reduction in CO2 emissions. Typically, by using a heat pump, you can expect to have a CO2 reduction around 60%. We can improve the quality even more by using, instead of gray electricity, which is just the grid electricity, by connecting your heat pump to a green electricity production plant. For instance, if you have PV on your roof, and at the same time, if you require the heat, you also can produce electricity. or you are connected to a water mill or another electricity source, which is renewable, then in that case, you can have a 100% renewable system. And that's, of course, the final goal of our energy transition. But already a nice step is introducing heat pumps and connected to the grids. As said, we will have at that time already a 60% reduction in CO2 emissions. Okay, that's the only the main technical part I will cover during this presentation. Let's focus now on what type of installations we have. As I said, so it was depending on the water type that we will have different types of installations. So we have systems which are connected to closed water bodies, canals, or, well, not a canal, it's more a lake, for instance, private owned water bodies, where we can have can insert a heat exchanger in the water itself and harvest or exchange the heat directly from the water body to the heat exchanger, and then distribute it to the facility. In that case, we talk about a closed loop system. So closed loop system means that everything is closed. We have a heat exchanger which is installed in the water body itself and is connected directly to the housing or to the facilities. In case that we talk about an open loop system, of open systems, at that moment, we are extracting water from the water body. We are pumping it to the land side, and on the land side, we have a heat exchanger which exchanges the heat then to the heat pump. And afterwards, we just pour back the water in the river itself. So we have a discharge of the water directly after the heat exchange. But as said, so we have an inlet point and an outlet point, and there is no heat exchanging directly in the water itself. So that's the main difference between a closed loop and an open loop system. As I said, also the open loop system is mainly used if we work in rivers. Closed loop systems are mainly used if we work in closed stagnant water bodies like lakes. But we can also have, of course, types in between. They are different in approach or in design. So it means also that we need different types of hardware for operating both systems. So in case we work with a closed loop system, is like I said, we have the heat exchangers, and you can see them here on the picture on the left side. So those are the heat exchangers that we have or we're installing, and it's before the final installation. So you see still the top side of the exchangers. After the installation, they are at the bottom of the water body and are fully invisible. But as you can see, it's already a large size equipment. And so in this case, it was around 25 square meters that we used as an obstruction in the water body. That's a heat exchanger for the closed loop systems. And that heat exchanger is directly connected to the heat pump. In case we work with an open loop system, then the installation is more complex. In that situation, we have as a first part a pre-filter in the water. That's our inlet point. We will take the water from that point, and so the filter is connected to a pump, and it's pre-filtered, so it's already to avoid that large particles will be entering the pipings of the entire system. So we have a filtration at that point around 1 millimeter, 1.5 millimeters. Once the water is in the pipelines, then we will have a distribution, and it goes the water goes to a more fine filter. So it means that we will filter the water to a level of, and it's depending on where it is installed, between 20 and 100 micrometers. So it's really to avoid that all contamination, all small particles which are present, and it's of course that it's logic that they are present because it's a natural waterway. And it's the particles are just some leaves from the trees, which are just filled are shredded to very small particles and are floating in the water. So we really like to avoid that. Why do we like to get rid of all those particles to that small level? Is because we do the heat exchanging in the heat exchanger itself. And the heat exchanger is a narrow plate heat exchanger. So we have all very thin plates close to each other at a distance of smaller than 0.5 millimeter. To avoid that, we create some obstructions in that heat exchanger. That's why we need to do the filtration in front of that. We work with this type of heat exchangers because they are the most efficient ones. So they are very efficient in exchanging the heat, but they are also a very expensive equipment part. The main reason why they are expensive is because they are made out of titanium. They are made out of titanium because the water can have corrosive properties, and to avoid that we have corrosion in the installation, so we have to use the most noble materials to avoid that we have corrosions somewhere in the installation, and also at that time, of course, have leakages. So it's a very critical part in the installation and needs to be protected as much as we can. After the heat exchanger, then we also have a connection. So that's a second circuit, which is connected to a heat pump. And that's, of course, at that time, we don't have any connection anymore with the river water. So it's a complete clean system at the second side of the heat exchanger. So as you can see, it's a very simple polypropylene. So it's a polymer heat exchanger that we can put in the river or in the water body itself, or we have to create an open system with a lot of equipment to avoid obstructions in the heat exchanger. Still, it's connected to the heat pump, and as you can see, actually a heat pump for this type of buildings, it's 100 kilowatt. That's not a huge installation. So those are very condensed systems, which can create already a huge amount of energy. How do you compare both systems? Well, you can already guess based on the information I gave. So for closed loop systems, we will have a heat exchanger in the water body, while an open system, it is on the land side. Because the heat exchanger is in the water body, we have obstructions in the water body. So there is a huge obstruction there, which can create some problems. So if you use these obstructions on rivers where also boat traffic is, so then it can interrupt the boat traffic, and also, or the heat exchanger can be destroyed about the boat traffic. So that's why it's an attention point. In the open systems, we have a very minimal obstruction, and so it's only that inlet points and the outlets, the discharge point, that is a small obstruction that we have. A big advantage of the closed loop systems is that no filtration is needed, so that makes also that the operational costs are very limited. In open systems, there a lot of filtration is required, so that's makes the operational cost more expensive, and it's also one of the reasons why it's only used when the power demand or the heat demand is high enough, so that the investment cost is worth to do that. And as said, it's a closed loop system will be used on closed water volumes like lakes for the majority of the projects, and open systems. So that's for flowing water bodies like rivers or canals, and it's always because the obstruction can harm other applications of the water body. Right, that's the system. But how do we get energy in that water body? Well, it is actually, you can see it as a thermal battery, which is charged by the surrounding, by the environment. And so mainly it is the sun that is heating our water bodies. and it gives us the specific temperature. But also from the ground, we can have an amount of energy which enters the water, and the air on top of that can sometimes also influence this. So there are a lot of inputs and outputs for the amount of energy which is stored. But of course, also the property of water itself is that it can store a huge amount of energy in a small amount of water. And so that's very interesting. We, as an engineering company in Extract, are specialized in developing digital twins in order to evaluate what is the thermal potential. And so we know on every location what are the input and output fluxes that you can expect. So we can calculate the reference temperature, or the temperature which you will have today in the water bodies. But also we can then enter an aquathermal energy system on that water body and evaluate what is the impact of that. And that's what we simulate, and what we will see, what is the influence, and try to avoid that the temperatures are changing that too much according to what is allowed by regulations, but of course also allowed by the ecosystem. So as said, we would like to maintain the ecosystem's quality, but also at the same time trying to have a useful case of an aquathermal system. So it's always an optimization point here. And so the idea is that we first start with an empty battery, and it's a water body which is not charged by the environment, that we evaluate when it is in contact with the surrounding, what becomes the potential or the amount of energy which is there. So that's our natural amount of energy that we use then in a heat pump. And by adding a small fraction of electricity, we can use it as a heat application tool, or we can deliver the heat to the different houses. So that's the idea, and it's actually a closed system. Once we take out some energy for it and bring it to the heat pump, it's unbalancing the equilibrium. But if we do that at a small amount, nature can recover and can bring the energy level back to its original position very fast. And that's so it's always an operating point that we are searching for. As I also said, we are living very close to water bodies, and this map represents that very well. It's a map for the city of Leuven, a city in Belgium, and also the city from where we are operating as Extract. And what you see is the blue line in the middle is the River Dale, which is flowing through the city. And you see the boundaries of the city itself. And then the red squares are identifying the amount of energy or heat that is required on that position. And what you can see is that really the high demands that we have in the city are very close to the water body. And so you saw the boundaries of the city itself, but also you see a blue zone which goes along the river. So that's a zone of a distance of 1 kilometer from the river itself. So actually 67% of all the energy demand is closer or than 1 kilometer away from the banks of the river. So that's really what proves us that there is a lot of demand on aquathermal energy. And if we calculate and also what is the potential of the aquathermal energy, then we also see that same demand can be provided by the river itself without destroying the ecosystems. And that's a play field we have with aquathermal energy. We have aquathermal energy systems, but they are very dependent on existing regulations. And as it is a very new source of heating, it means also that the regulation itself is in evolution, and so it's still in development. The regulations are country dependent, so every country does have its limited amount of rules at this moment. We see because with the project, we are doing a survey of the different regulations are present in the countries. We see big differences between the regions, between the countries, but even in a country itself, there can be regions, and there we also see big differences. If you take the example of Belgium, we have the Flanders and we have the Walloon part, and there are different regulations present there. And it's our goal to have a good overview of all the different rules present. Most of the regulations are temperature-based, and that's also logic that they are temperature-based, because if you maintain the temperature level or try to limit the temperature differences, there are a lot of parameters which are directly connected to that. Think about the oxygen level or the amount of nutrition that you can find in the water. They are all really linked to the temperature level. So that's our goal is also to not harm the ecosystem. And strange enough, rivers, they cross country borders, but they are not stick to one or another regulation. So what we see is that you can have regulations in France, you can have the regulations in Belgium. They can be different, but they are talking about the same water body. So that's also one of our goals, is to come to an overarching framework which works for all the different countries. So as said, there is regulation in countries present. We are still working on to make it more defined. And if there is regulation, the regulation comes most of the time from cooling applications. And so using surface water for cooling installations instead of what we try to do to use it as a heating source. Let's dive in for the last 5 minutes to a specific case in which I hope I can tell you and create or improve your enthusiasm in aquathermal energy systems. I would like to dive in a case in Leuven, is the town where we are working. It's the Dijlenmolens. It's an apartment. It's an apartment building where we have 35 apartments. It's 35 apartments together with a small shop. There is also a bar. There are some three offices, so it's a multiple used for multiple application used building. So it makes a very interesting profile, and of course they are living on top of the water body itself, and so they are very close to the water. And you can see a picture here, and it's very important also. There was an eager association of co-owners, eager in the sense of they were very willing to have a sustainable heating source in their facility, and so that's they were an energy community as we are looking in this project. So to give you an idea, so that's the front side and the back side of the application. As I said, and so the entire building is constructed over the river, so you can't be closer than that to a water source. It is a building which is connected to a river, so it means that we have chosen an open loop system in this case. An open loop system, as said, is made out of 4 parts. And so we have the main filter, or the first filter. So it's a 1.2 millimeter filter that we installed there, and it's automatically flushed and cleaned. Then we have the aquathermal skids, which is in the heating facilities installed. There we have a filtration still till a level of 50 microns, and there's also the pump is installed there, and we have a flow rate of the pump between 10 to 20 cube meters an hour. So at full load, we take 20 cube meters of water at an hour to power the entire building. But of course, we take the water, and 1 second later, it is discharged in the water. So there is no use or there is no consumption of water. There is only the use of the water for a certain amount of time. Also, that part is automatically flushed and cleaned, and so to lower the interventions that are required. Then we have the titanium heat exchangers, which I discussed already a lot in detail. So, and where we will have a temperature difference of 3 degrees Celsius. The 3 degrees Celsius we have there is due to the regulations or the permits that were given. As said, then this heat exchanger is connected to the heat pump. In this case, it's a 90 kilowatt heat pump with which can provide 80% of the total heat demand. There is still a gas boiler as backup or for peak loads. It was an experimental case, so it was also one of the questions from the owners to have a kind of fallback scenario all the time. So that's why the gas boilers are still there. And the supply temperature is a 50 degrees Celsius. Although it is a rather old building, the 50 degrees Celsius output temperature was more than sufficient enough. Just to show you how it is organized or on the positioning. And so we have the inlet filter, which was in front of the old or the former water wheel, which was installed there. Then there's some piping that goes in the technical room. You have the skid there, the heat exchanger, and then at the back side of the building, we have the discharge points. Project started. It was operational still from the 15th of November, and we had one winter of full testing, and it proved that we could, on a very convenient way, heat the entire building without any interruptions, and also the comfort that the people discovered was very good. So everybody is actually there. The energy community is there, very happy with the results. So this is the case. As said, as part of this project, we are looking for early adopters. The early adopters we are looking for are in all kinds of ways of energy communities. It can be people already be part of an energy cooperative. It can be an association of house owners or anything else, as long as you can identify yourself as an energy community. So our goal is to find 15 energy communities distributed over the different member states of the Northwest Europe region. And we would like to give them or learn them about aquathermal energy and give hands-on mentoring and technical support in the development of their own projects that they are thinking about. And we will do that by creating visits to project pilot sites. And as I mentioned, so we will have the pilots in Belgium, France, and the Netherlands. And so we will take them along the development of those projects. And at the same time, we will also organize master classes to give them all the insights of aquathermal systems and extra trainings depending on the questions they have. If you are interested in becoming an early adopter, you can use the QR code we have here, and you can scan that, and then you see the application form. Or you can also use the link which you have here in the slides, and then you also will find the application form and gives you the opportunity to apply for being an early adopter. The application period runs till the end of May. We have an evaluation period in June, July, and the first activities with the early adopters are planned to be in half of September, beginning of October. So we hope, of course, to see all of you there as an early adopter and bring you along this journey of aquathermal energy systems. But maybe and probably there will be some more questions, and then, of course, we are willing to give an answer on those. maybe the best is that I stop the sharing, and then people can ask questions directly, or you can type them in the chats, and then we can answer them. So I saw already a question from Ronald. The Netherlands aquathermal energy critical for our CO2-free district heating networks. Indeed, so especially in the Netherlands, the aquathermal energy is already on the roadmap of the energy transition, and is investigated as or is seen as a very interesting source, because also you have a lot of water, of course, in those areas. Freeze. Yeah, indeed. So that's also sometimes what we discover, and that's what I try to explain with the case. So everybody can read the chat, I think. So he's planning to have a project in Amsterdam for 150 apartments. For him, he said, okay, the technical part is not an issue. It's more the non-technical parts. That's also what we found out in the case of in Leuven, the Dijlenmolens, where we as an engineering company had a solution, but bringing it operational, and as this was one of our first projects, it took us around 3 to 4 years to really realize this, and the majority of the time was in convincing people, bringing people on the same line, and also finding an appropriate business model. This knowledge, and also the knowledge that we will gain from the development of the pilots, will be transferred to all the early adopters, and we will pay a lot of attention on the non-technical part, but more on those regulations, social issues, and so on. But of course, we're also very happy to hear your feedback or your experiences on how you work with that. Indeed, and so Ronald, it's a multi-shareholder case all the time, and so because you in most of the cases you are using public owned water bodies, so it means also that the government is very well involved in the development of the project. You require a lot of permits, but also before you can have a permit, you need regulations. And regulations can only be created if people who make the regulations also understand what are the limits and so on. From our experience in Belgium, and then more typically in Flanders, we worked very close together with the water authorities. We created a community of water body owners, and they are different type in Flanders, together with we as engineering companies, and we started to talk about with each other. What did we model? What are the results? Then we asked them, what is your interpretation about it? What is your understanding of this? And by up and forward discussions, we come to a regulation which is beneficial for the ecosystem, but also give a lot of opportunities for aquathermal energy systems. And that type of information we will, of course, also share with the early adopters. Your question, so the question from Mélis Meunier, he's asking about the possibility of using seawater. Seawater can be used for aquathermal energy systems. The installation that we showed here are mainly focusing on freshwater bodies, and so on water from rivers. There are some extra pre-treatments required if you would also use seawater, mainly. So it's the corrosion can become a very big problem. But not only the corrosion, and so the salt in the water, but also the sea fish, so the seafood which is there, or it's mussels and something like that, because they start as very small seeds, but then can grow very fast and large, and can create internally in your system. They can create obstructions. That means that extra treatments are required, but we try to do that on a mechanical way and not on a chemical way. But then, of course, there is a lot of seawater, so the potential is very, very high, of course, also. And so you will not use seawater for very small projects. You only will use this for very large systems. Then we have the question from Koen Hebrechts. Is evaluating aquathermal energy, or asking for how can you compare aquathermal energy systems compared to others? Of course, as you said, availability of water is key, but it doesn't need to be always the same like the dilemmas where you are living on top of water, and you can, in the surrounding of water is enough. You can develop heat networks from long distances, which are then at one point connected to the water, but can distribute the heat over a longer distance. But still, if you just would compare aquathermal energy to other systems, like, then there are two options, or using a heat pump and connect it to an air system, or using a heat pump and connect it to a ground system. On the economical side, we see that aquathermal systems are in between the air systems and the geothermal systems. So for most situations, the cost of the project of an entire aquathermal system is equal to the cost of a geothermal system, but then only for the drillings. So not the piping and the heat pump and installation costs. So there is a big gain in investment cost that you can have. But also surface water is present. It's an open source. So it also means that it's in direct contact with the environment, and can also be very fast and quickly be charged by the environment. So it means if you extract the heat out of your water body, it takes you only a few hours to get that energy back in that water body by sun radiation and so on. In a geothermal system, it takes you more than a year before you have that energy back. So it also means that you can really use it in one way. An aquathermal system can be used in one way, and the regeneration, it's done by the nature itself, as in case that you stay in between the limits. For instance, for a geothermal system, when you extract the heat out of the ground, you also have to recharge the ground, and that can be done, for instance, during summertime. So the recharging is necessary to maintain the energy balance in the ground systems. And that's a part which is quite a lot forgotten, and that also will have an impact on the performance. Then we have the question also from Dries. He asked, how was the investment structured in Leuven? Did the users invest, or was there some means of financing with an external body like a bank? Well, in the Leuven case, we had the luck that we could prove the technology by having a fund from the Flemish government. And so for the hardware was funded by the Flemish government, but only the aquathermal energy hardware. All the backup infrastructure was an investment from the owners itself. That makes the entire project. But in the evaluation, in development of the business case, we always created the or worked with the idea that we don't work with finances or subsidies from the government to evaluate if it was an interesting case or not. But we had the budget, of course, for experimenting because it was a first time design. So it was also, yeah, we have to optimize during the development. But still, if we would redo it now, it can be done in a financial beneficial case. And then the question from Melis Meunier again. So did you base the equipment sizing on the needs of the building or on the power you could take from the body of water? For this case, for the elements, we did indeed, we focused on the heat demand of the building, and based on that, we developed the system. But it's an interesting question because you could do those also, of course, in the other way. Why not making a system which is larger than the heat demand of the project itself, generate the heat and distribute it to the surrounding neighbors. At the moment in the situation that we are doing our master planning exercises, then of course we always focusing on the potential of the water body and then trying to find use cases in the surrounding area of the water body. But here in this case, we did it from the heat demand on, or based on the heat demand. So very good questions. And those type of questions, we are really willing to discuss more in detail during the master classes. So I don't see any urgent questions at this moment. Thank you, Dries. So we will distribute the presentation after from tomorrow on to all who registered for this webinar. On that presentation, you can find the link and the QR code for the registration of the early adopters. But also on the website of Aquacom, you can find the names of the partners. And in case you have more technical questions, feel free to contact us, and we are happy to answer you or to help you. Thank you for your attention. Thank you for being here on this seminar, on this webinar. And we hope many of you to see in our first visit in Vlieland on September, October.
Thank you very much, Sam.